Okay. All right. Hello, my name is Mark Freeman. I'm a member of 50 by 30 Niagara and Biodiversity and Climate Action Niagara, and I'll be your host tonight for this webinar on renewable energy, talking about solar and wind power in the Niagara region. We'd like to thank you all for joining. We are grateful that we are joined tonight by two very knowledgeable speakers, including one from right here in the Niagara region. After a few opening remarks, I'm going to turn it over to them. If you have any questions for today's speakers, please type them into the chat and we'll get to them during the question and answer portion of the webinar once the presentations are done. If you prefer, you can also raise your hand during the Q&A session so that you can ask your question verbally. As Liz said, this webinar is being recorded. So the reason we're holding this webinar this evening is to discuss alternatives to using natural gas or nuclear technology to generate electricity. There are very good existing alternatives that are very attractive, both from an economic and pollution perspective. First thing we need to do is acknowledge that as Niagara region's population continues to grow and residents and businesses transition to heat pumps to efficiently and cost-effectively heat buildings, the region's electricity demand will continue to increase. To meet the demand, we need an increase of inexpensive clean energy, ideally from locally generated renewable power sources. We believe that non-polluting solar and wind power combined with energy storage is the most cost-effective and quickest way to meet the challenge. We should also note that after phasing out coal plants 10 years ago, Ontario enjoyed a clean electricity grid. However, in the last 7 years, power generation from gas plants has increased from 4% to over 12% today. And we're currently on a trajectory of having 25% of our electricity generated from fossil fuels by 2030. This is drastically increasing air pollution, including climate impacting greenhouse gases, as well as discouraging investments in the province as companies are looking to reduce their carbon footprint. There is a better way. Even the International Energy Agency, historically a big supporter of fossil fuels, understands the importance and urgency of transitioning to renewable energy and the electrification of everything. We really do need to get on board. And with that, I'm going to introduce our first speaker for the evening, Chris Caners, General Manager of SolarShare. Chris is the Director of the Ontario Co-operative Association, where he champions alternative and cooperative business models. He's also an executive in residence with Foresight Canada, a clean tech accelerator for climate solutions. Chris is an instructor of greenhouse gas accounting and reporting at the University of Toronto School of Continuing Studies, and is also an independent consultant advising clients in greenhouse gas accounting and mitigation, the energy transition, and community finance. Chris has more than 15 years experience in climate action, energy solutions, and sustainable finance. As General Manager of SolarShare, he guides a non-for-profit cooperative that runs more than 50 solar projects supported by over 2,000 members and $80 million in community financing. With that, I'll hand it over to Chris.
Thanks so much, Mark. Really great to be here with all of you. Thanks for taking the time to come out. So like Mark said, thanks for that nice introduction. My name's Chris. I'm the General Manager of SolarShare. SolarShare is a not-for-profit cooperative here in Ontario. We own, operate, and finance solar projects like the one you see in the screen here. This is one of our projects. It's a smaller one on Manitoulin Island, about 10 kilowatts, and it's a dual-axis tracker that tracks the sun over time and over the year and over the day. So before I tell you more about SolarShare and talk a little bit about, I'm going to go through residential, commercial, and industrial solar. I'm going to tell you a little bit more about why I really love solar and why I think it's so great. So actually, my mother-in-law sent me, she knows I work in solar, and she saw these, she likes historical stuff and antiques and things, and she found this magazine, and she was reading through it, and they talk about Bell Laboratories' work in making solar electricity, and they enthuse about how there's no moving parts, and it can theoretically go on indefinitely. And that's one of the things I love about solar. It's it's quiet, it's distributed, it can go anywhere. And this is from 1954, October 1954. So solar's been with us for quite a while. Oh, sorry, I hear someone on the oops. If someone could mute them, so I think there's some background noise. Thank you. So I started really getting interested in solar when I realized that anyone can generate solar electricity, and that's one of the things I love about it. I think it's an amazing technology. I had the privilege of living in Kenya for a couple of years, and while I was there, I worked with a company called M-Copa, M for mobile and Copa for lending. And what this company did is it sold and financed these solar systems that you can see it on the screen here. It's a small array with a battery, with a couple of LED lights, and some cell phone chargers for all of the different connections that we all have for our devices. And this was truly amazing because it really unlocked solar on a scale that in Kenya, where it can leapfrog the grid, like people are using kerosene for interior light. So this replaces that. If you wanted to charge your cell phone, you might have to walk down the road for a mile or two to find someone with a diesel generator and charge it there and wait. And this is a whole different way of doing it. And it was very interesting because it unlocked the way that the secret of this company was that they unlocked financing for this product using the cell phone network and the banking system that was actually more advanced than what we had in Canada back in 2010. So luckily for us, solar has taken off since then. It's really, last year was an incredible year. 428 gigawatts of capacity were installed last year. And it's truly remarkable. As Mark mentioned, the IEA does like to make predictions about the uptake of solar as well. And they've been historically and tragically continuously wrong on how they've been much more conservative than how fast solar has been taking off. It's really amazing, and it's further incredible, I think, is that solar since about 2015, or renewable energy, sorry, since 2015 has been the largest source of new installed capacity in the world. And you can see that blue bar there in 2023. Look how much more renewable was installed than non-renewables, and most of that bar is solar. Now, we have to be careful. This is capacity. It's not kilowatt hours. So there's a difference. Solar doesn't operate all the time, like say the nuclear facility. So you have to be careful we're comparing apples and oranges on that sense, but much, much more capacity. It's obviously taking off. This is a global kind of phenomenon. And this is the reason why. There's a consulting firm called Lazard. They publish annually a cost of different types of power generation technologies. And for a long time now, it's been solar and wind that have been the most cost effective compared to any other type of generation, including nuclear, natural gas, whatever it might be. And so that's been true for a long time. And you don't have to look to these are sort of global trends, but even here in Ontario, the IESO, the Independent Electricity System Operator, is well aware that the cost of solar and wind is lower than any other type of generation right now in Ontario, and that's only going to continue to be true and get more true as we move out over time and have to meet the electricity demand that Mark referred to as we electrify transportation, as we electrify homes. We're going to need more electricity. And so that's a really great thing for solar and wind because they're quite cost effective. So cost effective that in places like Germany, where the price of electricity is much higher than in Ontario or in Canada in general, this has taken off. They've installed 200 megawatts of balcony solar in Germany, where it's much more you plug it in basically to your socket. We don't have the regulations in place in North America for such a system yet. But truly amazing that 200 megawatts is a big number. In comparison, SolarShare has 15 megawatts of capacity. So that's truly incredible. And just so now, that's not the way it normally works. You don't normally just plug your solar panel into our socket here in Ontario. That's not how it works. What we have is something called net metering. This is very similar to other places. around the world. What happens is we have sunlight that hits the solar array. It generates direct current. That direct current gets converted through what's called an inverter into alternating current, so it then can be put onto the grid and put into your home. And what happens is basically we have whenever we're generating more electricity from our solar array than our house can use at that time, it's exported to the grid. And when the solar array isn't producing as much power as we need at home, we take electricity from the grid, hence the net metering component. And this is the way that you would do residential solar in Ontario. So I love this. This is one of our SolarShare's board members, Ashley Reed, at her home in Kitchener-Waterloo, with her brand new solar rooftop installation. I think it looks great. Here is the general cost. This is in cost dollars per watt, roughly, very roughly, for solar in Ontario right now. The bottom line is that most of the cost actually comes through the design and installation of the array, and then there's a bunch of other stuff like the panels, like permits, like installation. We think we can do better on permits and the cost and the time involved with doing this if we ask the government to do some things that will help that. But rooftop systems are typically 7 to 12 kilowatts in size, and the installed cost is around 25,000 to 42,000. So they're not cheap things. And so it's a hard, one of the big problems for solar in terms of uptake is the upfront capital cost, because lots of people don't have this kind of money lying around. And unfortunately, one of the problems is our friends at the Ontario Clean Air Alliance they do a lot of great work. They published this study recently looking at solar arrays on rooftops. And unfortunately, I wish I could say the payback periods were better, but they aren't as good as I would like them to be at this point. This will continue to improve over time as the price of electricity goes up and the costs of installation go down. Nonetheless, a 20-year payback isn't really great. So you have to look for other, if you have that kind of money and you're passionate about solar power like I am, then maybe you would make the choice to do this, and I encourage you to do so. But we do need other incentives, not incentives. We need better regulations that'll allow us to deploy solar faster. So I encourage you to take a look. PV Watts calculator from the National Renewable Energy Laboratory is a great resource. You can look up your address and figure out some of the system characteristics in a general kind of way. I encourage you to check out the Canadian Renewable Energy Association Go Solar Guide. They publish one every year, and it gives you lots of good information on residential solar. And then there is also, and I know Mark is going to mention some of this stuff too. I'm going to try and sprinkle it through my talk here. The Canada Greener Homes Loan, up to $40,000 interest-free, up to 10 years. You need to have a home energy assessment before you can access that, though. Okay, so that's a high-level summary of solar. What about commercial? Here's a picture of a SolarShare project up in Temiskaming with our operations, some of our operations and maintenance employees there looking proud after they've made sure that the system is operating at maximum output. And you can see that, again, these are dual axis trackers. This is more common in commercial solar. Typically now it's a bit more of one axis, so it follows the sun over the time of day. These ones here follow the sun over the course of the year as well as over the time of day. It's a pretty cool system made by a company here in Canada called Morgan Solar. Here's an example of a rooftop system on a commercial industrial facility, more of a commercial facility in Brampton, Ontario. And you can see all these solar panels there, and there's lots more room. We would love to put more solar panels on roofs like these. Here's one that's close to, that's in Niagara, we call Vinastra. It's just to give you a sense, you can see the anemometer, the weather station down at the bottom. So just to give you a sense of some of these kinds of commercial scale facilities. So really, when we're talking about a commercial facility, we're talking about something on the order of, 100 kilowatts up to a megawatt kind of thing. That's about what would fit on a regular rooftop. The cost is lower. It's not $3.50 a watt. Now it's about $1.80 a watt. It depends, obviously, on a range of factors. So just keep that in mind. In the case of commercial solar, what you can start to access now, if you're a business owner, you can look at something called the Clean Energy Investment Tax Credit, the ITC. So this is something that was introduced by the Canadian government as a response effectively to what the Americans did with the Inflation Reduction Act. So these are refundable tax credits for the capital cost of solar projects. There's a whole bunch of other types of projects in here too, but basically you can get 30% or 15% in some cases back on the capital cost of your solar project, which is a huge deal. So that makes things much, much more cost effective for commercial business owners. Depends on, really depends on the price of electricity and how you operate and that kind of thing. The other nice thing, though, is you can do accelerated depreciation of solar assets at this kind of scale as well. The other thing I wanted to mention, SolarShare is keen on working with municipalities, and municipalities are doing some great work out there. Look at things like the Green Municipal Fund. They help to fund studies and capital costs for different solar programs that are led by municipalities. So that's something that you should be aware of if you're interested in getting more solar at your municipality. The other thing about commercial solar is it can be put in places at scale that are really interesting, like solar parking lots. This is one at Centennial College in Toronto. Our friends at the Ontario Clean Air Alliance also wrote a report very recently about the potential for rooftop solar in Toronto and to displace the use of the Portland's Energy Center, which is a gas-fired facility, and they want to expand it. If we use solar rooftop, solar and parking lots in Toronto using some pretty conservative assumptions, I'd say, you can overcome that. You don't need to expand that gas facility, and we can have clean distributed solar, sheltering vehicles where we need it, which is pretty cool. The other thing I love about commercial and industrial solar scale projects is that you can do stuff like agrivoltaics. So this is just a fancy word for doing agriculture along with solar PV. You can see these are our sheep at one of our projects. There's more studies being done by places like Western University or the University of Guelph that are doing, looking at the other kinds of things that you can integrate solar with agriculture in really interesting ways. Again, with industrial solar, the cost drops again, probably about $1.20 a watt. So as you get to scale, we're talking really 10 megawatts or above, probably 100 megawatts, many tens of megawatts at least. You get the same kind of incentives in terms of tax credits as with commercial. But I wanted to also mention that the government of Ontario is right now leading a series of procurements for electricity in Ontario. It's not specifically about solar. They procured a whole bunch of storage recently, and then they're doing several rounds of different procurements for different types of energy sources, up to 5,000 megawatts over the next 10 years or so. So that's being done at that provincial level. Here's a solar farm I wanted to show you. This is an industrial solar farm, about 100 megawatts I visited recently. And look, they're using sheep as well. Really cool. I love that. Love that agrivoltaics. Okay. So wanted to tell you briefly about SolarShare, not-for-profit cooperative here in Ontario. We own and operate 51 projects across the province. We generate about 17 million kilowatt hours annually. We've paid back $13 million worth of interest to our investors and raised more than close to $90 million now, and a community of more than 10,000 Ontarians. We were established in 2010. Here's a map of all our projects. You can see them all the way from Niagara region up to Temiskaming and over to Ottawa and out on Manitoulin Island. So we have quite a variety of projects with all sorts of different types of equipment. If you want to check that stuff out, please visit our website, solarbonds.ca. You can see here at the bottom right, we publish all of the information from our solar projects, so you can see them operating in real time with pictures and everything. It's pretty fun, if I do say so myself. You can also look at our website for investment opportunities. What we do is we issue bonds, we call them solar bonds, to any resident of Ontario, and that's how we finance our community solar projects. As a cooperative, we're democratically run. And the way that we finance those projects is by raising money from our members. So right now we're offering two different options right now: a 2-year term at 4.5% simple interest per year, and a 5-year term of 4% interest, simple interest per year. We've sold out of our 3-year 5% bond, and so I encourage you to check out our website again, solarbonds.ca. Final word before I'm done my bit here. What can government do to help with these different these issues. How can we speed up the deployment of solar and other renewables? So what we'd like to see is lower cost connection fees for projects that are small. We'd like to see simplified and accelerated permitting for smaller projects as well through the Ontario Energy Board. With the government of Ontario, so what came out recently in August was the government of Ontario has banned solar projects from prime agricultural land. This is a pretty significant issue. It means, I think, that municipalities have to reassess the land on which a solar project might be located. Now, it's not to say that we want to put solar on every piece of agricultural land. I don't think that's a good idea. But I think there's lots of opportunity for things like I just showed you, where solar and agriculture can coexist. And that's certainly important in Niagara region, obviously. Pay net metered facilities. So right now, when we install solar on a rooftop, there's a load. You can't generate, well, you don't get paid, excuse me, for any electricity you generate more than you consume in a given year. So we think that exports that are net, even if you generate more than your facility consumes in a year, you should have the ability to sell that power. So we can build the project I showed you before, we can add more solar panels and export more to the grid. One thing that I really am keen on is something called virtual net metering. This means that SolarShare, for instance, could set up a project in some part of Ontario and sell all of our members electricity virtually. And that would really help us deploy solar faster, and we could sell directly to our members, which I'd love to do. Facilitate deployment of distributed resources. There's lots of ways we can use batteries and solar, car batteries, all sorts of stuff to manage grids and avoid having to make big capital cost upgrades by using the distributed resources that we have at our available. And of course, I'd love them to continue to support community-owned solar like SolarShare. Thanks so much for your time. I really appreciate it. I look forward to your questions. Once again, I'm Chris. I'm from SolarShare. Please don't hesitate to reach out. That's all my contact information for you.
Thank you, Chris. That was awesome. I really liked the comments about the policy and regulations that we could improve on that makes solar much more attractive in Ontario. And I really like the comment you made about the agrivoltaics. That's fairly new for me, and learning about some of the things that you can actually grow underneath the solar panels. So anything that likes shade, for example, right, is good for growing underneath solar panels. But anyways, thank you very much. And as you mentioned, you're available for questions. So if folks have questions for Chris, please put them into the chat.
I see one from Wayne here. Thanks for that question. So Wayne asks, can you talk about the waste recycling of solar panels and any other environmental impacts of the replacement of panels? That's a great question. So solar panels are made of three fundamental components, really. It's glass, aluminum, and then the silicone and other metals that are used to actually make the solar panel and generate the electricity. So the aluminum and the glass are easy. Those are commodities that we know how to recycle, we know how to use. That's not a problem. The problem is the rest of the stuff, and it's sort of integrated into these layers. So solar panel recycling certainly is something, though, that you can recover like close to 100% of the actual materials. Solar recycling right now is starting to take off. It's not something that's common right now. I wish I could say it was. The problem is that, like I was showing you before, the volume and scale of solar panels available for recycling is not of a sufficient scale yet that you can sustain a business on it. But we're rapidly approaching that point. There are people in the industry. I was just at an operators meeting the other day of big solar operators in Ontario. Everyone wants to find the recycling facilities to do this. It is a little bit of a problem right now. But my opinion, as we move forward in time, similar to like batteries, battery recycling is a thing. We are going to be able to recover a lot of those minerals and metals that we need for the energy transition and continue to recycle them. So Right now, it's not happening. But that's for economic and scale reasons, and that will certainly start to happen over the next little while. The other thing I'd like to say is that the difference between solar and say something like gas is that once you burn the way that we get the energy out of gas is by burning it, and that the products of combustion end up in the atmosphere. And it's very, very hard to take, CO2, which is at 420 parts per million, out of our atmosphere. That's a very dilute solution to take that back out of. So that's extremely expensive, very difficult to do, and rather not pollute our air with that, with those products. With solar, you don't have any of that getting into the air or the environment. We can recycle almost all of it, although that hasn't been happening right now. It's going to in the future, and redo that process. So I'm very bullish on solar recycling as we move forward.
Thank you very much, Chris. So yeah, my name's Herb Sawatsky, and I'm moderating the Q&A here. If you have a question, just throw it into the chat or put up your hand. You can do that. Use that icon, and we'll pass the question off to Chris. I will, however, highlight something that Angela Bischoff has posted into our chat. Angela Bischoff is with the Ontario Clean Air Alliance. They're strong advocates and have had a campaign to triple offshore wind. They figure that can go a long, long way to meeting our electricity needs. And so Angela's organization, Ontario Clean Air Alliance, have done several different reports on parking lot solar and on rooftop solar. Chris, question for you since we have the time here. Can you comment on parking lot solar as well? I know that there's some installations happening out in Europe, that it's being advanced there. I know that because I know a fellow who's connected to that. I'm wondering if you're able to talk about the capacities and the potential for parking lot solar as well. I would just think that with rooftop solar, yeah, the potential is pretty vast. If you look at how big our parking lots are too, the potential. Yeah, go ahead. I'll hand it off to you. Do you have any comments there?
Sure. I can't claim any special expertise on parking lot solar, and maybe Angela has some comments, but I encourage you to go and read. There's a report that was released that you can check that out and get more details. So, but in general, parking lots are spaces where there's, people would like some sort of a structure to protect their vehicles. Typically, it's wide open. You can get lots of good solar potential there. And in fact, you could combine that with solar, with electric vehicle charging, et cetera. Again, distributed, so you can place them in places that help manage maintain the grid and manage different capital expenses, and so you can deploy them strategically like that. So I think there's a lot of really great reasons. There are, as I mentioned, these are being developed and deployed in Canada, in Alberta, in Ontario. There's been a lot more development in Alberta since the cancellation of all of the FIT contracts here in Ontario. So there's lots of work being done there. As you mentioned, there's lots of much more in Europe as well. Again, the prices of electricity in Europe are much higher, so you see that kind of uptake of those kinds of interesting cases more quickly in Europe as well, because they're a little bit more aggressive on some of the climate targets than we are. So you see that kind of uptake, which is really great. Yeah.
Awesome. Yeah, Angela has put a link into our chat regarding the triple wind and solar campaign. You can click onto that and then join and participate in that, and also sign on to the Ontario Clean Air Alliance, where Angela and co are doing a whole lot of great work. Jordan is wondering about the impact of tariffs that tariffs might have on the cost of solar in the near future. What are your thoughts on that? We're all jumping onto the tariff
That's
bandwagon right now.
that's a great question, Jordan. I mean, I'd say it's a dynamic situation right now. I haven't dared to look too closely at that kind of. I assume you mean tariffs from our friends in the States.
Hmm.
Yeah, I mean that did have a pretty significant effect, as far as I'm aware, when Trump was first in power. Um, right now, as far as I'm aware, solar panel prices are quite low because the American market has restricted itself to a certain extent. So there's a lot of solar panel manufacturing occurs in Southeast Asia. And so that has meant a reduction, as far as I'm aware, in solar panel prices for us. So what further developments might mean, I don't really know. I'll certainly keep a close eye on it, but sorry, I'm not more informed about that.
Yeah. I am I right on this? I think China makes about 90% of the solar panels. They keep two-thirds
That's
of
right.
that, install that in country, and the remainder they export. And so really they're installing about
Mm.
two-thirds of all solar panels as well. Does that sound right, Chris?
I mean, directionally, right? Jordan's saying he's saying that Canada proposing tariffs on Chinese imports. Well, to your point, but I mean, that sounds like it would be a problem for cost. So, a good question, Jordan. I'm not sure about that, but that's a very, very interesting to know about.
Okay.
Um, yeah, and I see Brett asked, what potential does solar have to bring down the cost of electricity? Like I said, for residential, it depends on what you're talking about. For residential solar, challenging. Um, right now, there are circumstances where it may work. But what I'd say is, solar has more potential to bring down costs at a commercial and industrial scale right now. So if we deploy more solar commercially and industrially, then that should reduce the price of power over the long term.
So another question I've got, I'm a layman, so a couple of things I can't quite wrap my head around. You mentioned that it costs about $3.50 a watt to install. So we're looking at about, oh yeah, for a 10,000 watt system. Um, but so it's going to cost, so what's the math there? $3,500? No,
So it's like a 10 kilowatt system is about $35,000.
35,000. Okay, all right,
Mhm.
one more zero, $35,000.
Yes.
How many kilowatts would that produce in a year?
About it would cover more than the average household. An average household would use it's what is it, 700 kilowatt hours a month.
Okay.
So 10,000 or so would cover you
And so 10,000 is what it will produce in the year.
roughly. You'd get a
So,
rough, say about 1,000 kilowatt hours per kilowatt, very roughly speaking.
okay.
You produce. So if you had 10 kilowatts, you'd probably generate about 10,000 kilowatt hours.
Okay. So when
Herb,
we,
Herb, is it okay if I interrupt you here?
yeah, go ahead.
Yeah, thanks. I just want to be able to get to Jordan. We can come back to all the questions that
For
we
sure.
have, and I apologize. It seems if I try to share my screen, my computer locks up. So I'm not going to share any slides. I'll just talk. Um, so we'll move on to Niagara's own Jordan Beekhuis. He's the director of Rankin Integrated Energy. Jordan is a professional engineer and director of sustainable development within the Rankin Group of companies. He has been working in renewable energy development in the Niagara region for close to 20 years now, developing, constructing, and operating wind, hydro, and solar PV projects throughout the region, resulting in a contribution of over 600 megawatts of renewable energy. Jordan's experience in postgraduate work studying sustainable energy technology and markets in Europe from 2015 to 2017 at the Delft University of Technology in the Netherlands has helped shape his views on what Ontario must do to succeed in fully transitioning to sustainable energy. So Jordan, with that, please take it away.
Unmuted. There we go. All right, let's see if this sharing works here. Can everyone see that? Hopefully. All right, as mentioned, I work for Rankin Construction, and to make things more complicated, I work for Rankin Renewable Power, Vineland Power Incorporated, Wainfleet Wind Energy, Rankin Integrated Energy, and far too many companies. But let's just keep it simple so expectations are low. I work for a local heavy civil contractor, so presentations aren't necessarily my thing. But this is a quick map just showing rough locations of where wind projects that we've worked on throughout Ontario are. As mentioned in the intro, about 600 megawatts of the 5 gigawatts approximately of wind power in Ontario, we've had a hand in as a contractor or in some way, shape, or form doing piling roads, whatever else. But today we're going to focus on the Niagara region as this group's focus and also where I'm from. So again, a bit of a tangent as we do actually renewable energy, wind, solar, hydro, everything else. I can't really talk about the Niagara region without talking about the sort of energy history and sort of powerhouse here in Niagara, which is hydropower. These two water bodies, the Welland Canal and the Niagara River, have the large OPG, Ontario Power Generation assets on them, which I think we just need to sort of appreciate how spectacular this area is. And I like to put it in the context of the Great Lakes where we all live. We know there are these massive freshwater bodies, really unprecedented in the world. But one thing that's interesting to point out is when you take this section view, you can see that really it's about 183 meters of drop in elevation over several thousand kilometers. And of that, pretty much over half, about 100 meters of that drop occurs just in the northern little section of Niagara here, where Niagara Falls is, which gives us sort of this historical status as a hydro generator. Starting from the left here, if you guys aren't familiar with these, DeQ Falls has that age, that history to it of 1898, I believe, is when it was constructed, and it's still operating today. Off on the right-hand side of this screen, you'll see the Sir Adam Beck Station, which is about 2,000 megawatts or 2 gigawatts. So one of the backbone of our clean energy infrastructure in Ontario. And in the middle is an interesting one that is all too often overlooked, a giant battery made of water right in the middle of Niagara Falls that people drive around every day. Essentially a pump storage hydro facility called Sir Adam Beck PGS, which uses water, the ability to pump water uphill and store it for a later time to manage our electricity demand. But we haven't stopped there. These are a couple of pictures of some newer facilities that Rankin actually built along the canal. So again, my apologies, it's not all wind here. Just to cover this here, in between Sir Adam Beck and DeQ, we have the remainder of the Welland Canal and down into Port Dalhousie, another 5 stations. The Seaways station to the south is on the flight locks, and that's from about the 1930s. The Haywood generating station is actually owned by the city of St. Catharines. And the Weir 1, 2, and 3 stations are built by and owned by Rankin Construction, or Rankin Renewable Power. Well, let's put that in a wider context of the Niagara region. And don't worry, I'm getting to wind, but just trying to sort of set the context here. This is sort of where our hydro potential, our hydro assets are in the region on the northeast. But we still continue to burn things. Just running through some of the other contracts and resources we have here. The green icons here actually denote biomass or biogas facilities. So digesters that are taking biomass and turning that into gas to be used for both electricity and often for heat. The landfill gas, things of that nature. All of the red icons here are natural gas facilities, most of them cogen, meaning they are producing not only electricity but heat for the facilities where they're located, whether it be an institution like Brock University, or the just small agricultural or large industrial facilities. And we have one really large natural gas plant, the Thorold Cogen. And I put that in quotes because that's what it's called, but they haven't had a heat off taker for that for years. So they really just produce electricity, whereas they have the capability to provide heat. They don't have an industry to actually do that for. So that one's honestly a bit of a disappointment there. Just to touch on the solar, as we've already went through, just to show what's here in Niagara, I only put icons here for the ground-mounted solar because it'd be very difficult to identify where all the rooftop solar is in the region. But just for a matter of scale, these 5 projects you see there are about 12 megawatts. That's one 10 megawatt project and 4 half-megawatt projects. But if you look up to the top of the screen here, I've listed that there's about 60 feed-in tariff projects. Those would be commercial rooftops, your big box stores, or those sort of medium-scale solar projects. And there's approximately 10 megawatts of solar there. And then there's about 1,000 microfit. And if they were all as large as you were allowed to build them under the small program, 10 kilowatts, that would be another 10 megawatts. So on solar, we pretty much have 10, 20, 30 megawatts in that range of solar in the region scattered throughout. And finally here, I get to the wind side of things. These here are the first two wind projects built in the Niagara region, the HAF wind project and the Wainfleet wind project. They both consist of 5 wind turbines and are located on the shore of Lake Erie in the one case, and just on the sort of extreme west side of the region in the other case. A bit of an overview shot here just to show you what this project's all about. As I said, it's 5 turbines per project. They each produce about 2 megawatts per turbine, so 10 megawatts total. But I think we need to give some context to what exactly does a megawatt mean, and how do we compare this to what we use in our everyday life? Well, I have a slightly different numbers. I'd say about 9,000 kilowatt hours per year is what the average household in Ontario uses. It's a little more than you're suggesting, but in the ballpark. And these projects are about 9 to 10 megawatts, meaning that 9,000 kilowatts being 9 megawatts, if this plant is running at full power, every hour, this plant would produce enough energy for a house for a year. So let's say the wind blew all the time, we would actually be producing about 8,760 homes per year worth of energy, but the wind doesn't blow all the time. So we have to take into account the ups and downs of the wind. And in that case, we get about a 36% what we'd call capacity factor, meaning that we produce about 36% of that maximum if we were to run at full capacity the whole time. So in the end, these little projects of 5 turbines each produce enough energy for about 3,200 homes, or about 6,400 homes combined between the two of them. I may be jumping around here a bit, but I'm just going to say we're not the only player in this. I'll put it in context here by showing the grid, the electricity grid, or transmission grid at least, within the Niagara region. The red lines are sort of the higher voltage, 230,000 volt lines, and the green lines are the 115,000 volt lines throughout the region. And all of those dots there that you see are transmission stations, or the areas where it goes from that high voltage down to the lower voltage that goes out to all the houses. You can see the wind projects are sort of out in the middle of sparsely populated open lands and far from a lot of this infrastructure. So one of the challenges when we were looking to put in these first wind projects is, even for these small projects, there wasn't a lot of capacity. So we looked between, Crowland transmission station, you can see down there in the south, and Dunnville, and pretty much, had to fight to get a little bit of capacity on either. Same thing with the Niagara transmission station that we connected to with the HAF project. So when people started to mention to me that the Niagara Region Wind Project was out there to put in turbines across the region, I actually told a few of them, well, I know the grid pretty well. I don't think you're right. So I had to eat my words on that one, because what I didn't realize was they had had a little bit of foresight, and they built the project large enough that this large project of 230 megawatts actually connects into Hamilton. So they built a transmission line along with the wind project in order to get out of the constraints of some of our grid capacity issues here and connect this into Hamilton to provide one of these big projects. But still, it is located in Niagara. And if we were to compare this to the households in Niagara, it has the potential to produce about 35% of all the households in Niagara could be powered by this wind project here of 230 megawatts. So just a quick overview shot of all that sort of mix of what's here in Niagara as we go on to talk just more about wind for a second. Yeah, let's do a bit of a glamour shot here. We were doing some blade inspections, and our drone operator likes to get creative and do these nice panoramics. But what this shows is 2 things. First off, a bit of simplicity. When it comes down to it, a wind turbine only has a few major components. We have a foundation underground, which I didn't show you here because, well, it's buried. A large tower to hold up this nacelle, which is the big box on top, essentially, where the generator and everything's housed, and the rotor, which turns that generator. The other thing I'd say it really shows is scale. When looking at solar, you have really an advantage that any scale works, but really scales down well to be able to put it on your household or anything else. With wind, it's not so much an all of the above options for scale. You really do need size to make it cost effective. The reason that wind has been coming down in price and is Now, one of the cheapest forms of energy is really because as you scale up, as you build taller, and as you extend those rotor blades out, it becomes much, much cheaper. This turbine that we're looking at here has a 100-meter rotor diameter. So that's a football field on top of a football field height tower. It's a 95-meter tower as well. And by today's standards, this is a small turbine. So the new turbines come in at about 170 meters and can be anywhere from 4 to 7 megawatts. This is a 2-megawatt machine, as I said. And the newest turbines offshore, the largest out there, I believe, it's about a 250-meter rotor and 20-megawatt machine. Now, I don't know how many of those have been built. I think it's just a one-off, but that's really where these wind turbines start to shine is as you extend that rotor just a little bit, you capture much, much more energy. But there is some complexity. When I say it's just a rotor turns a generator, obviously there's a lot of details in that. One thing is it needs to point into the wind. So if you look in the bottom of this, it says yaw drive. Those motors, they are what turns the nacelle to point into the oncoming wind direction. There has to be sensors on top of the turbine that detect that wind direction and control it. You have to actually worry about the cable going down the tower because as the turbine rotates, that cable is twisting up. So it actually has to keep track of how far it's twisted from its nice relaxed state so that it can unwrap in time to not stretch that cable. So you'll actually see these sometimes just stop and then just turn in a circle for a minute. Well, they're just unwinding their cable because they've been turning around too much. Probably the most finicky part of a wind turbine and one of the most important for efficiency and for safety is the blades. The blades, not in terms of the aerodynamics, but the blade pitch system. So all modern wind turbines, they can articulate each of their 3 blades, either hydraulically or electrically. And because that's spinning around in sort of 2 different axes at the same time, you often have sensors and just challenges. There's always backup power on each blade, whether that's hydraulic reservoirs or batteries, to make sure that in the event of a complete power failure, you have triple redundancy to be able to stop the wind turbine if anything were to go wrong. And that going from that rotor, we go to the generator. In the case of a gearless machine, and actually in Niagara, most of ours are gearless. That's the 230 megawatts are all direct drive, meaning they have a generator directly connected to that rotor. Whereas the lower cost option, but a little less reliable, is to use a gearbox. So that's more common in the world. And that's what we have as well, which is a gearbox that connects to the main shaft and to a smaller, lighter, higher speed generator. Just sort of an overview of the different components there. I'm going to shift gears up here a little bit and just talk about where that resource is. I love the visualization that this Windfinder site gives just for, honestly, just simple weather reports. I just pulled a day that showed a bit of our predominant wind direction is usually out of the southwest. So you can really easily see the effect that the lakes have on the wind speed and why a lot of the wind turbines in Ontario are located where they are. If you've ever been down near Chatham-Kent, near Windsor, you'll see that there's turbines pretty much everywhere. Up near Kincardine, there's large wind farms. Over by Wolfe Island on the other side of Lake Ontario, large wind farms. And obviously Niagara here gets a lot of that benefit from Lake Erie as well. So just giving some context to why they go where they do and how that wind is reacting. Now, we don't do offshore wind in Ontario here yet. I'm sort of 2 minds of it. I think it's not great that was stopped for political reasons, and we should be exploring it. But also, we do have a lot of land in Ontario, and onshore is much cheaper than offshore. So there's likely there's an in between where we can consider all our options and find what's best for everyone. But a lot of land is not necessarily what Niagara has. This is just to give an example of some of the things that we have to consider when siting a wind project. These are all the buildings in Niagara, probably not a very accurate representation, but this is from a public database of buildings as a GIS file. And this is a 550-meter setback superimposed on top of each of those buildings. And that's the minimum distance to a residence for a wind turbine. And you can see it really eats up a lot of the space in Niagara. The little green patches in between there start to seem sparse. Especially when you start to consider that these aren't the only restrictions. You need to make sure that you have proper setbacks from environmental areas, from roads, from property lines, from things like airports obviously need need a bit of a buffer there. So this is all things that need to be considered. There are certainly more areas that could accommodate wind turbines in Niagara, but it does take a lot of work and know-how to find those areas that are a correct fit. But this is the complicated part in the boring slides. My apologies, but essentially I needed to put it in there as it's very timely. As was mentioned by the previous presenter, Ontario is finally, after many years of not building anything and sort of letting the system degrade and gas become our dominant, more and more dominant in our system, they're looking at procuring new energy. So they started putting out requests for proposals, and they put out information on the grid to give people a hand as to picking locations and where to install things. You'll notice here in Niagara, they haven't really given a lot of credence to wind being a new option they want to consider. This is not actually a preference. This is what they're suggesting is right for the grid, but there's a lot of things, a lot of assumptions that go into it. Niagara is getting a lot of upgrades as well, so a lot of transformers and other things that are reaching an age of replacement, but also expanding some of our capacity down to the southern part of Niagara. They're going to be essentially doubling some of those circuits from 115 to 230,000 volts so that they can take more power, both for industry and potentially for generation. But the overview is not great from a perspective of what we can bring to Niagara at a large scale. These circles are where the system operator and Hydro One have said this is how much space we have left to build various new generation projects of all kinds. And there's big circles around several areas, which includes the GTA and Niagara, that says areas to avoid. So we have some work to do here. I strongly believe that this is overly conservative and that there are some priorities in here, like maintaining capacity for gas that's existing and sort of assuming that they'll be on full time in here, which I think with the right motivation and with people expressing their preferences, we could certainly prioritize cleaner sources and free up some room that way. But right now, just so you know, it is a hard sell to put the renewables in the areas where they're really needed for servicing customers. This is just a very simple chart I threw together. Seen many versions of this in textbooks, but I just made this from 2 random projects that we have because we do have wind, solar, and hydroelectric stations, and just threw them in as percentages just to show, obviously, the preference for solar to be much higher producing in the summer, the wind to be much higher producing in the winter. And the beauty of that is when we balance things out right, if we put in a good supply mix, we can take variable generation and smooth it out, especially on a long-term and seasonal basis, using things like batteries and my preference, which you'll see in the next slides, for dealing with shorter-term variability of hours to days to weeks, things of that nature. So this is sort of going back a few years because I made this slide for a different presentation. And when we were talking about having too much generation in a way, because we were at 95, 96% non-emitting electricity with all the wind and solar we had added to the grid and some of the nuclear coming back online. There's curtailments. We were actually shutting down wind and hydro at certain times because we just had too much. And what we were trying to push as the message, which they didn't see until recently, was this is actually the demand we have to address. It's not just that electricity portion on the side where 144 terawatt hours of electricity we're currently producing. In order to address climate change, we have to actually figure out how to address the needs of transportation, natural gas, all of our primary energy supply, which, electricity is only about a fifth. So it sort of shifts here from saying we're almost done electricity. Look, we're at 96% to, wow, this looks almost too big to handle. So the good news is we can swing it back the other direction for a second as well. And that is by looking at efficiency. So I'm just going to throw transportation up here on the side and recognize that, when I look at the energy use of an electric vehicle versus a gas vehicle, it's actually more like a 5-to-1, but to be conservative, I'd say at least 3-to-1 improvements you can expect when you electrify on a lot of these technologies. So if we do that, all of a sudden we shrink this down closer to 85 terawatt hours. And at the time when I made this, again, this was pre-pandemic, but again, I'd have to recheck the numbers, but at the time when we were curtailing and selling net exporters to the States in the range of about 22 terawatt hours with our existing capacity and with clean energy. That means we could cover about 25% of all of our transportation needs with the electricity we were producing at the time. So again, it's not going to be a small ask to cover the rest of it, but it does make it seem a lot more manageable than, having to expand the grid by, 4 or 5 times. It's more like a doubling of the grid that we have to figure out in order to accommodate all of these fossil fuel energy needs that we currently have today. So as I mentioned, we expect batteries to be one of the ways that with wind and solar we can address variability and we can make sure that energy is always there when we need it. But I'd like to stress to everybody, and again, this is a bit of a tangent, it's not specifically about wind, just about the broader context. But I'd like to suggest that actually the best resource we have for making sure that energy stays cheap and that we make it cleaner is actually enlisting the customers. And what I mean by that, just so that no one jumps down my throat on this, is not that we have to all sit in the dark and wait for the wind to blow or the sun to shine to flip on our lights. The fact is your lights, your phone, your television, all those things you use directly, even, cooking, really those are small energy uses by comparison. The beautiful thing is as we're in this transition, the really big, really easy to move energy needs are things like electric vehicles. So I currently have 150 kilowatt hours of batteries to charge in my driveway in terms of 2 electric cars. That compares to 24 kilowatt hours of electricity I use in my house. So really, the one completely dwarfs the other in terms of the needs of energy in that scenario. You then move to thermal storage. The fact is, as we said, we're switching to heat pumps, but as we electrify, there's also many options to actually make it so that you can sort of charge your house or save that heat or save that cooling potential so that you can use renewable energy when it's available, and they can be much cheaper than electric vehicle or than batteries. Industrial has all kinds of options, but it's very specific to the industry. Industrial heat is a big part of it, and there's a lot of companies now looking at industrial thermal storage for those applications. Simple examples, even things like we've been storing energy for a long time as things like pressurized water in water towers, just so we don't need to size the pumps for the peak demand. And after all of that, after the cheapest options that are going to keep things simple for us, we can always go to batteries and chemical means, hydrogen production, all of those sorts of things. But I just wanted to lay this out because I think until we make that connection, until we connect the customer with the generation source, as long as we keep them isolated, it means we are going to have extra cost or at least additional cost to what it is. Batteries are getting a lot cheaper. So I think it will still certainly work. But if we want to have the cleanest, most cost-effective system, I think we have to put all these options on the table and show that we can actually contribute and all be part of the solution. So where to go from here? Just a couple of quick final points. Sustainable energy is inexpensive, as was actually pointed out much better by the presenter before me. But what I was trying to point out is it does require change. We want to do it cost effectively. We're going to have to think about it differently. That's the same for the utilities and for the system operators. We have a lot of resources, but utilities basically say if it's not fossil fuels, we have to somehow squeeze it in to look like fossil fuels and work like fossil fuels and cost like fossil fuels and do everything the same. And that's obviously a way to make things more expensive when you have to try and fit it into a box it's not designed to and not optimized for. And finally, what we've seen a lot is municipalities. It's nothing against them. And municipalities, the easiest thing to do is when there's change is to simply say no to it. And unfortunately, that's turns out to be the case all too often now. And I think it's up to all of us to go out and talk to municipalities and suggest to them, not a specific solution, but that we really need to come to the table and find what's the best energy mix and supply that is going to work for our area. And don't just reject things, but try and come to a solution that works for everybody. Anyways, that's all I've got. So I'm going to stop sharing here and see, I guess, if there's any questions.
Yeah, thank you very much for that, Jordan. On that last note that you made, there are at least, I think there's two counselors here from Pelham. I know for sure that one. I think one, yeah, I think we might have two counselors here, and yeah, they're both. One of them is deeply passionate about the power grid and getting the power grid basically ready to meet the needs of Niagara. As you know, the population in Niagara is going to shoot up. Here in Pelham, we're aiming for 29,000 people by 2051. I think most of Niagara is going to close to double. So there's a lot of electricity that needs to go in. Um, in terms of power generation, Chris had a panel up on the levelized cost of energy. And I think I saw on there that solar and batteries together would be $45 a kilowatt on the low end. And I think that works out to 4.5 cents a watt, right? And right now our electricity price is about 12 cents a kilowatt, right? Or a watt, right? In our bills. Or what are we paying? What are we paying at home for our electricity? Can I throw that one to you, Jordan?
Sure. Yeah, so what you're paying at home in your electricity really depends on how engaged you are in picking your electricity rates. Um, so I just see that my video just went fuzzy. I'll see if I restart that. But essentially, we have the ability to choose between three different rate structures in Ontario. So if you would like a very simple rate structure, you can have a tiered rate structure, which says, and I don't know if I have the numbers exactly right here, but I think it's something like your first 750 kilowatt hours is about 10 cents a kilowatt hour. And then it goes up to maybe 12 or 14 cents a kilowatt hour for more energy than that. You have time of use rates, which again, I don't know the exact amounts, but I think typically I see the average being around the 13 to 15 cents a kilowatt hour. And one of the very interesting things for people who are active enough to be on a call like this is there is what's called the low overnight rate. Hopefully, many of you have heard of it, but essentially, if you have something like an EV, you can actually get a very low rate in the range of 2 to 3 cents a kilowatt hour throughout the middle of the night. So from 11 p.m. to 7 a.m., you get a very, very low rate. So that's what I'm on here with those electric cars I have to charge. I also have my HVAC system filling a giant 100-gallon tank of water with hot water for the next day. I also have my hot water heater for showering and everything else on a contactor that only turns it on in the middle of the night and has nice insulation, so it'll ride through the entire next day and give me all the hot water I need. There's all kinds of fun things you can do with that. And right now, unfortunately, it's just a nighttime energy is cheap. But where that's going to go in the future is energy is really cheap at times when it's abundant. So in places like California, where solar is very prevalent, you have what's called the solar duck curve, basically meaning that during the middle of the day, when the sun is really shining, you get this huge depression in prices because there's so much solar on the system. Well, in a place like that, you might want to turn on your EV charging or heat your hot water or, you know, run a small business that uses energy or whatever else during that time when it's cheap there. And it does start to sound really complicated. And I do want to stress that I don't think everybody's going to become an energy nerd and do this. What I think is much more possible when we see the embedded electronics and controls and capabilities we have in sort of everything we buy nowadays is that people who are entrepreneurs, when the pricing structures are there, are going to sell products that do all that for you. Meaning, you know, you buy your water heater now that a lot of them actually come with Wi-Fi, so you can set them off, set them down, turn them off when you're on vacation, things of that nature, right? That's all becoming more common. I think, you know, often your fridge has Wi-Fi nowadays. But to do useful things with that, like have it manage when your EV charges, that's pretty much standard on electric vehicles now. There's no reason for it to not be tied into the way we build our HVAC systems and everything else so that there's an algorithm running in the back or even an aggregator, as they call it, which would have control over a huge range of water heaters or other dispatchable loads and manage them for you and then give you a dividend and payment to have your load be more dispatchable and benefit the grid so that it doesn't have to spend a lot of money to have power sitting there waiting. And usually that's trying to pay gas to sit there waiting. Now we can just say, hey, we don't need you sitting there waiting, because a lot of our stuff that we don't really need right now, but we do need it over a certain time, it's getting managed in the background. It's getting
Mm.
shifted around as we need it. And that's where I really think those low-hanging fruit are, if we can get our act together and promote it.
Yeah, and getting our act together is a big piece of it. Angela Bischoff has posted in the chat a few more items and studies as well, uh, saying that offshore wind farms can be located 10 kilometers offshore, and we need to lift the moratorium on offshore wind. And yeah, basically what you're saying, and the point I was getting to when it comes to wind and solar and battery storage, they easily fit inside of our current price point in terms of our electricity costs and production. If I remember this right, Ontario is one of the only jurisdictions in the world that is not expanding its offshore wind. It is going up absolutely everywhere, except for Ontario, and Canada overall is doing very, very little on it. And it's a way, well, we're wasting an opportunity. In terms of, all right,
I do
go
see a
ahead.
question there.
About the birds, yeah. Ask
I
Wayne
didn't
wants to
see
know
that.
Wayne
I had to
wants to know how many
scroll up for it.
birds we're killing. Go ahead.
Yeah, no, absolutely. So the question of birds getting killed by it is something that has been extensively studied. So that's one of the first things to note. So we had to, as every wind farm in Ontario had to do, we had to actually do bird studies for the first several years of operations, and just to understand what kind of rigor that takes, what kind of detail that takes. We had to have consultants that went out through the entire sort of summer season and would walk around these turbines. Now, actually, it's been enough years that I'm still trying to remember exactly how many times they do this, but they'd walk transects of a couple meters apart, and they'd have to search for birds and identify any that they found. And it wasn't really just as simple as that, because they also had to go and actually get, and they need special permits for this, but they would go and get birds from a certain ministry. And these were bird carcasses, and they'd mark them and tag them. They'd have to distribute them around under the turbine. And then they'd have to come back and check on them periodically over time in order to get a calculation of how quickly birds were picked up by scavengers, by coyotes or other animals that would come around and pick up the dead birds. They'd also have to do searcher efficiency trials where they would take these marked very small, like it's actually quite incredible how tiny these little birds are, basically camouflaged on the ground there. But they distribute them around the tower in certain numbers, and then the searchers would be sent out to search without knowing what was there. And then after the search, they'd go back and see how many they missed. So when we actually would find a single bird, it would get multiplied by this question of, if we found one, we must have missed X number because of the number that would have been picked up over that time period by scavengers. Plus, we probably only found this percentage of it, which, if you can't search the whole area under the turbine, might be a very small percentage. And then even after those assumptions, to make sure that we are taking account of the possibility of missing some birds, we're talking about a couple of birds per year. And I don't want to belittle, I don't want to make that sound like a small thing, but when you're comparing that to cars, house cats, I've been driving for a while. I can't tell you a long road trip where I haven't had a bird glance off the windshield, unfortunately, when you're traveling across the country, sad as it is to say. But realistically, the numbers don't support that wind is bad for birds unless you're talking about poor sighting, meaning certain species of birds, obviously raptors, things that reproduce very slowly. Even a few mortalities for something like eagles can be problematic. And so that's something that's taken very seriously and managed. So whether it's shutting down turbines, actually radar tracking when large birds like that are coming into the wind farms and stopping them. But realistically, it's not an issue beyond sort of the windows on houses. All those things are infinitely more detrimental to bird populations than properly sited wind projects. So yeah, we really just have to be careful to site them appropriately.
Yeah,
Awesome.
and
Thank you,
Jordan,
Jordan. Go ahead,
I
Mark.
think Jordan, I think I've also seen reports that say that even just house cats, are responsible for more deaths of birds than wind turbines, even near large wind farms. So I think that's a myth that we can put to bed. I wanted to thank you, Jordan, for that really that overview of the energy landscape in Niagara. That was really helpful to understand what we have here. And I think the common message from both yourself and Chris has been we really need some help, some government policy help, some regulatory help in order to really expand renewables, not just in Niagara region, but across Ontario. I also wanted to mention that we did have in Ontario the feed-in tariff program, the FIT program, that was allowing independent renewable energy suppliers to connect to the grid. But Ontario hasn't accepted a new application for that since 2016. We had a microfit program for some smaller players, and that hasn't accepted new applications since 2017. So we have some challenges that we need some help with. The good news, though, from the government side is that Ontario does, and I think Chris touched upon this, we do have 30 energy storage systems currently planned for Ontario, and that's going to be providing about 3,000 megawatts of power. So that's good news. It seems to me what we're hearing is that we have had significant renewable energy development in Ontario, but right now we're stalled, and we need some help to get some motion again. Before we get over to some more questions, Herb, I just wanted to mention that I will be sending out with this recording some slides that have some data on it in terms of links, I should say. So links that have um, some more information around the cost overall globally, the cost of solar and wind relative to nuclear and gas peaker plants. And from what I've seen, the cost of solar and wind for electricity generation is about half the cost. So I'll send out that link for that. And also the links that Chris touched upon at the beginning of the call about what help are we getting from the government. And from the federal government, we do have some programs. Chris mentioned the loan program. That's still good. From a business perspective, there are a number of tax incentives that will help industry. The accelerated capital cost allowance that Chris mentioned. There's also clean technology investment tax credits, as well as clean electricity investment tax credits. So I will provide those links as well if there's anyone on the call that wants to look into those. One last thing I'll say on this is what's interesting to note is that the IASO, they have a local initiatives program, which is intended to help relieve stress on the grid in the province. And Niagara region is included in that. So a couple of comments there. First one is, to me, I see a bit of a red flag that the region is already constrained. We already have power constraints in the region. So something we need to be concerned about. The other comment is, if I was a business with a large roof or a parking lot in Niagara region, then I'd be taking advantage of that incentive. So I'll provide that link as well. I said that was the last comment. I lied. I have one more. The one again, a positive note from the Ontario's new Minister of Energy. He quoted just last month. He stated, I should say, and I'll quote, just last month, he said, "We are looking at giving every incentive possible to businesses to produce power for their own needs." And that applies to families as well. Oh, thanks, whoever put that up. Can you go to slide 9? So the new Minister of Energy has said that they're going to be providing incentives for providing power for their own needs. So I'm optimistic that there's some new provincial level incentive programs for renewables that are coming.
Is this the
Yeah, thanks, Herb. So do you want to go to the next slide? I think I've covered that, so these are the links that I'll be sending out. So if anyone is interested on the call of getting, can you go to 11? If anyone on the call is interested in pursuing solar panels, I will provide a list of some of the local businesses that are providing solar panels in the region. Okay. And the next slide. Thank you very much. So we hope that everyone's found this webinar interesting tonight, and we are going to get to some questions. I'm not cutting you off yet, but I did want to suggest that if you've been motivated by this call and recognize the issues that we're having, then you might want to help us facilitate this green energy transition by signing some of the petitions on this page. I will be sending out these links, of course, with the recording. The petitions are at the provincial and federal level from a number of great environmental groups that are working these issues. They include the Ontario Clean Air Alliance, Environmental Defence, David Suzuki Foundation, Canadian Physicians for the Environment, and Stand.Earth. We also have a letter that we are going to be sending to the Niagara region to help promote the development of a community energy plan, and you'll be able to see that details in the slides that I share with the recording. Last one, if you want to go back up to slide 13. Sorry, Herb, and I appreciate you going through my slides as my computer's giving me a hard time tonight. The last thing I'll say then is we'll also provide some links to some interesting resources if you want to do further look at renewable energy globally and in Canada. So with that, we should head to the questions that have been posed, and there's questions in the chat, but if you want to use the react button at the bottom to raise your hand, we'll look at those questions as well. And with that, I'll pass it back to you, Herb.
Okay, awesome. Yeah, Jordan made a comment about counselors, and I spoke a little bit to that, the fact that we have two of the counselors here. My own experience with counselors is that most of them are very open-minded. Like all human beings, we love doing things the way that we've always done them, and yet they also know that things have to change, but don't always know what needs to be changed. What I find with counselors is they simply know that voters have their back. Right? They need to know and they want to know that voters support them in the direction they're going. And there's a lot. So we need, in terms of getting together a community energy plan that incorporates things like rooftop solar, parking lot solar, wind farms, offshore wind. Our counselors, our businesses, they need to know that this is what the population wants, that this is what's important to us as voters. So I encourage you all to be speaking, be engaged with staff, be engaged with counselors, and let them know that you want to be a part of this. And when Mark sends out the links for the petition, the letter that we want to send off to Niagara, encouraging Niagara to get together on a community energy plan, put your name to it. Let staff know and let counselors know that this is something that we support. My experience is they do listen, and you can talk with them. So, all right, more questions for Jordan. None of them are showing up right now. So I'm trying to think of questions that we might have.
If I may, can I see that Brett and Linda have both asked questions. So Brett asked, how can we support industrial and commercial solar projects in Niagara? I like the idea of putting them on parking lots, brownfields. I mean, what I'd say is, energy or electricity is a provincial sort of jurisdiction issue in Niagara. So, I think talking to politicians, particularly at the provincial level, would be helpful in terms of regulations around that kind of thing. There's probably also permitting and site issues. I would talk with the local distribution company, and also, of course, if your local politicians at the municipal level are in support, that's very helpful. So I'd say generally the route, advocating through political officials. The other thing, so for Linda, she asks, to get policy changes at municipal and or provincial level, need to know what's in it for them, get policymakers on side, guidelines. Yeah, so I mean, what comes to mind is really jobs. Like when we're talking about renewables, what we're doing is we're generating electricity from resources we have in our province. And that's really great for our province. And I think other provinces and territories should do the same thing. So, the more renewable energy we have, the more jobs we have, construction, ongoing maintenance. I'd love to see more manufacturing. We do have some great manufacturers of solar and wind equipment in Ontario. We have that kind of base. So I think that's for me, policy changes at a provincial level or policy changes at a municipal level. The other thing I'd say is for municipalities specifically and SolarShare specifically, we would love to work with municipalities. For instance, municipalities often have rooftops behind the meter. And so you have like different recreation centers or whatever it might be. SolarShare is an organization that would love to work with the municipality to deploy solar on those different assets in a phased and strategic way with a partner municipality. You can do things like behind the meter and battery storage for resilience centers in bad weather or something like that. The other thing we can do is we can do through the accounting, SolarShare can own these assets. Municipalities often have a challenge with debt and spending money on this kind of stuff. So SolarShare is able to do that. I know it's complicated. There's lots of bureaucratic steps and constraints on us, but I'm very open to talking with any municipality that would like to explore that.
So did you just say that you would operate the solar installation as a utility?
Yeah, you can do what you can do is you can operate as you'd sign basically what's called a power purchase agreement. So SolarShare would own and operate the system over a certain period of time at a certain rate of electricity that we could sell to the municipality. And so we would have some skin in the game because we want to own and operate and maintain it. So generate as many kilowatt hours as we can at a rate that makes sense for the municipality. And if we can access grants through the Green Municipal Fund, etc.
Because Pelham is installing, and they're in process now to install solar panels on their Meridian Community Center. And I don't think they're working with SolarShare. But yeah, they're using grants from the Federation of Canadian Municipalities. And they're anticipating that equipment would be on the roof there for about 30 years
Yeah.
and be paid for in about 7 or so. Does that sound right to you? Did I understand that
It really depends on the incentives. 7 years seems pretty quick. It depends on what the price of electricity is,
Yeah.
and the cost of installing it. I see Ed asks about school boards and rooftops and school boards. Wouldn't that be a good path? You're absolutely right, Ed. There have been a number of solar companies that have done that. For instance, at the TDSB in Toronto here. And there are other school boards that have done that. I know in Ottawa there has been some of that as well. So that is also a great path for solar. Again, it has to be, we're on the commercial scale. Is it going to pay off very quickly? 7 years sounds aggressive to me. It depends again on on all of the characteristics, but it's going to be a relatively it's somewhat longer payback. So the interest for us is having a strong counterparty like a school board, like a municipality that's going to be around for a while and wants to amortize these assets over their useful life, which can be up to 30 years for sure.
Yeah. Well, and if you operate it as a utility, then that definitely lifts the cost burden from the municipality, right? And from the business and from the school board.
Yeah.
It helps them out in a really big way. Because they're often concerned about upfront costs, and if you're doing it that way, and that's how Enbridge does their stuff. And yeah, solar companies, wind companies should be allowed to do the same thing. I got to here. So that means the focus should be getting the right people on the school board. Well, and I know, and Alex Bradman is a great guy to have on the school board, as is. Mitchell, the Indigenous representative. She's also fantastic. There's great people on the school boards. Jordan, is rooftop wind at all a viability?
There'll be some who say it is. In my view, no. I think that when you scale down wind to a small scale, it's fun. It's a novelty. It can be done cost effectively if you're doing it in your backyard or a bit of a tinker. I have, a wind turbine like you'd have on a sailboat, one of the small phone chargers of a couple hundred watts. But realistically, when you're talking about cost-effective energy production, the only way I see small scale wind making sense is for remote applications where you need something like I don't know, a small cell tower or something like that, where you want to balance out your solar and your wind together because your solar is your cheaper, easier route, but in the winter it performs pretty poorly. So to put that wind and solar together, it may not be the most cost effective, but small wind has a place in things like that. And honestly, there's probably some niches where, you don't have to build a very tall tower if you're up on a hill or whatever else, and you have very good wind and you can put it up cheaply. But rooftop wind is just, I've not seen a good implementation of it. I'd be happy to be wrong. But typically, you're talking about a rotating mass on top of your building. Keeping that quiet, keeping that steady, it is not something that's simple or cheap. And so I'm not really a fan of rooftop wind. But hey, I encourage people to try try new things, but just be wary of the actual numbers and know what you're getting into, because a lot of small wind there's been a lot of stuff put forward in small wind, which is quite suspect, and I don't want people souring on the industry as a whole because it's really not the area where wind shines.
Okay. Thank you, Jordan. Liz talks about including renewables into green development standards. So a green development standard would basically be a requirement for a new building to meet certain green codes. So that would be more insulation, so that it takes less energy to heat it, and then also where that energy comes from. What do you guys think? Have you seen renewables being included into green development standards? Does that sound realistic or feasible to you? I also know, I'll throw this in as well, that I'm starting to hear builders complain that Ontario has this hodgepodge of green development standards from every different community having different ones. And so they're starting that, well, not, yeah, it feels a somewhat legitimate concern that they're having to meet different standards in different places. I kind of feel all of Ontario should just adopt Toronto's green development standards and then we go. But
Let,
yeah,
let me
can this be incorporated into renewables be incorporated into green development standards? So a greener building code for new buildings? What are your
so
thoughts?
yeah, so Herb, to complementing what you said, my understanding of green development standards is more about the house itself being a zero emission building, which means heat pumps instead of using natural gas as an example. But I want to extend that to say that there's not much point in using heat pumps to heat and cool our homes if the electricity is coming from gas plants. So, to me, that makes sense from a green development standard perspective, that we have to be aware that the electricity has to be coming from clean sources.
Sure.
I don't know,
I,
Jordan or Chris, if you wanted to comment further on that.
So as I mentioned, I think that in those cases, you'd really be talking about solar and maybe some other technologies in most cases, because as wind really doesn't scale to that. But we do have some experience. We do have a few solar plants as well. Um, but what I'd say is right now, your challenge, let me just say it. I would say absolutely yes. It's been done elsewhere. It should be done. And it's honestly the only way that where that technology gets made accessible is when it's standardized. Because when you're competing to build new homes, you have to compete with everyone else who's looking to build new homes. And if they all are meeting whatever the lowest common standard is, it's hard to add on things that make the project better. But
So,
unfortunately, right now, you're going to be in a position where you're struggling against the push for the need for housing. So to add on a requirement like that, I would say even in that case, there's room for it, but maybe it needs to be proposed with a removal of some other challenge. So push more on the environment and maybe get rid of more of the some of the other complexities that make it difficult and costly to build homes at the same time. Because the
well,
fact is, it reduces costs for people to live in those homes. And
mhm,
unfortunately, when we're trying to just get
mhm.
stuff built, we don't always necessarily give enough um, weight to that long-term cost effectiveness so people can keep their homes. So I would definitely see it as something that's a benefit, but it's going to be a very difficult topic to navigate in today's climate.
so again,
I
I think
think,
it's the resistance to change overall, whether it be with the utilities, whether it be with the regulators. It's the resistance to change that we need to overcome. Putting in a rough in to make a house net zero ready in terms of solar ready and EV charger ready wouldn't really take much and slow down development. Those are things that I had to get done on my house after the fact, and it was a pain. It should have been done up front. But anyways, that's my perspective, and I want to keep to the time frames. If there's no other questions, I don't see any.
Liz
Then
did have her hand up, so I wonder if she wanted to jump in. And I'm
I
wondering, Chris is
think
leaning
she's
forward. I
okay.
don't know if you're wanting to say something too, Chris.
So the only thing that when I was talking about green development standards, what I was talking about is requiring things like solar panels on buildings over a certain size, like Toronto has, Herb, like you said.
Mm-hmm.
If we could have a standardized green development standards across the province, that would work. And Toronto does require certain things for buildings over a certain size, for instance, green roofs, but there's no reason why we couldn't require solar panels on roofs over a certain size. So that's
Which is
what I
what
was
they do.
talking about. Through the development process, we could be requiring some of these things.
Which is also what they do in California and other places. Absolutely.
One last thought on this, and yeah, I think if we took all of the green mechanicals, like air conditioners, heat pumps, hot solar hot water, or a heat pump hot water, and if we took all those things and sold them as a utility, right? So they're not in the upfront cost of the house, but like like is done with hot water tanks, right? They're rented at an exorbitant rate, right? Which is ridiculous. But they could be function as a utility or rented to the homeowner from the date of purchase, and that rental agreement would go to the address of the property, right? So it would be sold to the next one. That lowers the upfront cost. And if the municipality manages that, they're buying heat pumps in bulk, which allows them to lower the cost of the heat pumps per unit. That to me feels like something that's pretty feasible and could be done. Um,
Sounds like ideal partnership with geothermal type of
yeah, yeah, absolutely.
building where the geo exchange is used for providing the heat and cooling for the heat pumps,
Yeah.
and then the company that developed that, or in partnership with the owner of the building, could run it like a utility. Absolutely.
Yeah.
And that is very common in geothermal now, actually. That's what we're considering for some of our new buildings. But exactly what you said, it's a fine line because there is an entity then that's looking to profit off it, and none of us like finances by 1,000 subscriptions, whether it to all these multimedia things or to a number of new utilities. The trick is to really bring the cost down, and if everyone's a good player in it, and the utilities are being reasonable with it, absolutely, that's a great path forward where it works.
Well, and I would go even further and make it a municipal utility, right?
Mm.
That runs like a co-op, right? It's the purpose of the co-op is to make sure that that the customer is taken care of. And if it has to be a private utility, so be it. But my preference is that a municipality run it like a co-op.
Sounds good.
Solving the world's problems. Did Mark
I think we
just go
just
offline
lost Mark
again?
again briefly, but we're past our 8:30 time here, so we should probably wrap this up. Hopefully, Mark can join us just to say goodbye. But thank you everybody for coming. If you missed last week's presentation, it was great, just like this one was, and it's available. We've got it posted on YouTube. So everyone who's attended tonight, you will get all the information that was presented tonight. You will get a recording of this, and we'll give you information about what happened last week as well, and where you can find that video. Hi, Mark. Thanks for rejoining. You're just
I
in
need a
time
new
to say
computer.
goodbye and good night to everybody.
I need a new computer, and yeah, I want to give a special thanks for everyone for attending, but also a special thanks for Chris and Jordan for spending your evening with us. So we really appreciate all the insight.
Awesome.
And with that, I will
Our
wrap it
pleasure.
up. Thank you very much.
Thanks, everyone.